Hi, Molly.
God.
Hi, everyone.
Hi.
You guys must have questions. Everyone's getting here early. Okay, you guys see my whiteboard?
Huh. Yes.
Okay. Hopefully things go faster than last time. Yesterday's Zoom, I didn't have any technical issues like on Monday. Monday was terrible. I'm gonna mute because I think that helped last time. So go ahead if you have a question.
Professor, I do have one quick question. Oh. Maybe I should just message it. Professor? Hello?
Sorry, guys. Sorry. You can hear me now, right?
Yeah, no, you're fine. I was like, oh, maybe she can't hear me. It says that the lab is due on May 31st, and I just wasn't sure if that was the
Oh
correct
no.
date.
This lab, no, that must have meant April 31st. Well, that would be too soon. Normally our labs are due, we've been having them do Sundays, right?
Yeah, that would work.
Yeah, it would just be Sunday night. I gotta fix that.
Okay.
Thanks for bringing it to my attention.
Yeah, no problem. It's like, that's a long time.
Yeah. Yeah, and in the spring semester, it's not like this in the fall, but in the spring semester, they give us 5 business days to grade everything. It's a really short period of time.
Oh, okay.
So we can't have that much due at the end.
Yeah. Okay. Okay. Cool.
And so that was your question. That was easy.
Yeah, that was my question.
Oops. Ah, my screens are like big. I'm trying to keep as many windows closed as I can because I think that hurt us last time.
Good morning, Professor. I have a question for you.
Uh-huh.
When you are doing this electron configuration,
Uh-huh.
uh, they have the full-blown complete way of doing it. Then they have the condensed where you put the noble gas in, and
Yeah.
then
Mm-hmm.
are both ways legitimate?
Both ways are legitimate. And on the exam, it's specified which way.
Oh, it will specify.
Yeah.
Okay,
I believe it's specified everywhere.
okay.
And you're going to upload your file, so you could always do both. If you have extra time.
Mm-hmm.
Let me let people in.
I have a question. Is the multiple choice 2 hours and then the free response is unlimited, or they're both 2 hours?
The whole test is 2 hours, but I've taken out the file upload time from the time limit.
Oh,
Got it.
I don't get it.
Is that not good?
Wait, I don't get it. Wait, so you do the multiple choice online and then you submit it, right?
Yeah, so it's all in Canvas, kind of in the same platform as the pre-lab questions. And there are multiple choice, and there are some there's some text and fill-in numbers in the online exam. But you're going to need to show your work. And so, for example, like I will ask a question in the online exam that says, draw this Lewis structure. Well, you can't do that on Canvas. So what you're going to do is label the question number on your exam, draw the Lewis structure on a piece of paper. There's a couple follow-up questions in the exam. Like, for example, I think in the actual exam, I say, tell me what the geometry is. And so you answer that part right there. But you have to upload the Lewis structure but you do it after you've done the whole exam.
Oh, okay. So so the exam actually has some free response like
Yeah.
things on it, but you upload it when you're done, and then what you wrote on your paper, you have as much time to upload that.
Yes. Yeah.
Oh, okay, that makes sense.
Yeah. It's someone else in the department has been doing it that way. And I think it took a little bit of getting used to, because anytime you are doing an exam and it's a new format, there's some anxiety. but
Yeah.
it seemed like it was the best compromise.
Yeah, that seems good. Yeah, thank you for that.
Yeah, and so the fact I have a timestamp because you are entering some part of that question during the time limit, and then the supporting stuff you can upload afterwards. And ooh, what was that?
Oh, sorry, that was me. I got a text. Sorry.
Oh, okay. I have very, very sensitive fire alarms here.
Oh,
So
that'd be bad. Sorry.
we have to have a technology issue every session, so I'm just waiting for it to happen. Yeah, so so I have a timestamp on the question, but then you can upload your file without stress and all that.
Okay.
Yeah, but just
Perfect.
the only thing that I think could be potentially tricky is just make sure you label your questions clearly so I know which one goes with which. Like
Okay.
question number 2 or question number 3.
Got it. Okay.
Yeah.
A couple of questions for you, Professor.
Uh-huh.
On this Lewis dot structure,
Yeah.
is there any particular way that you can attack this thing to get the right structure, or is it something that you pick up over the years with experience? Because some of these things I know what I need to do, but I don't know where to put the oxygen or the carbon. I know the hydrogens are on the end. Like for example, they had one. It was C2H3Cl. I looked at that thing.
C2H3. 3 what?
Cl.
Cl. Okay.
Now I did the electron count.
Uh-huh.
I got that correct. But drawing these structures, I didn't quite know where to start. I started with carbon in the middle.
Yeah, that's good. Carbon's always going to have 4 bonds.
So you got 2 carbons there.
Yep.
And I said, now, where do I go from here to get this thing to?
Well, so you know what? There's actually more than one possibility here.
I couldn't
So
see any one of them.
yeah, so if it's correct, I think if you check your formal charges and your formal charges come out okay, and you've counted the electrons correctly, you probably have a feasible structure.
Okay.
So like, for example, for this one, let's see, 2, 4, 6, 8, right? I used 8 electrons. I've got 6 left. I got to fill the outer ones first.
Right.
And so now I've run out. And I happen to know that everything has a formal charge of 0 right now. So if I just do that, I've got the right structure, or a suitable structure. And this actually might be, let me see what else would be possible. Oh, wait. Let me see. This carbon doesn't have an octet, right? Oh, it's 3. I was missing a hydrogen. Yeah, I think that's the only way it will work. Because if I try to put all the hydrogens on,
Right.
I won't be able to get an octet with the electrons I have.
Some of those dot structures run me ragged. Trying to get everything, put it in the right structure to get those electrons to add up to what they're supposed to be.
Well,
Sometimes I just can't see it. I have
tell
to
you, on the exam, there is only one central atom in all of the Lewis structures.
Okay. And one more question, Professor.
Uh-huh.
When you have something like CH2O2, I don't understand how, you need to put an
See,
octet. Okay, your CH2O2. I know
okay.
carbon is a central element,
Mm-hmm.
and I put the hydrogens on one side of it and the oxygens on the other side. No, I did it straight. I did it straight down. Oh, that's the way you do it.
Yeah.
You
I
can't.
think
You can't. So you would not use oxygen across from oxygen and hydrogen across from hydrogen.
hydrogen across from hydrogen.
So you got carbon. You have
Yeah.
oxygen on the top, oxygen on the bottom, hydrogen on the right, hydrogen on the left.
And then I have another oxygen. What'd you do with that?
Put it on the top of the carbon. Now that is not the correct structure to start with, correct?
No, it's not. It won't work. So I'm trying to think of how, trying to think of how I would know right away that it wouldn't work. I think I would think of this and go, okay, I know that my carbon can only have 4 bonds and that oxygen has to have 2, right? And
Yes.
and so probably the only way to get oxygen to have 2 bonds is to put put a hydrogen on one of them. It's trial and error, but this is really organic chemistry. If you get to that class, you get a lot more practice with carbon there.
Okay, because sometimes these Lewis dot structures can be tricky.
Yeah, well, there's partial credit. And also, if you get to a place and you know that something's not right, just put a note on your structure that goes, I can't figure this out, but I know that this structure is not correct because of X. Then I understand that you know that oxygen has to have 2 bonds, or that something doesn't have an octet, but you can't figure out how to rearrange the atoms. But like
Yes.
I said, all the structures on the exam have only one central atom.
Okay. Like this one we just did, I would approach that. I would not have done it that way. I would have had the hydrogens opposite each other and oxygens opposite each other, and then struggle with it.
Well, try not to commit to one arrangement, but I think it's not, I don't think that that's going to be an issue on this exam.
Okay.
What else you guys got? How was the practice exam?
I thought it was pretty good.
Good.
Yeah.
Okay, well, I'm holding my breath for this Canvas exam because I don't have a whole lot of experience writing them. I took it twice. Just mainly for to check that it works. So if you do run into issues, email me right away. We'll do the best we can. I think it's going to be okay though, but I'm a little nervous just about the technology part of it because it's all new. And the process of putting it together is pretty exhausting. It's not as emotional as taking it, but it's but it's a lot of work. What's the toughest part of the material for this?
For me, it seems to be putting in the correct dot structure. When it's very obvious, it's pretty simple. When you start getting into things like, C2H3Cl and things like that, I'd said, okay, where do I start? Where do I start first?
Uh-huh. Now, I don't think we've spent a lot of time going over resonance structures. Are you guys comfortable with resonance structures? Do you want to see an example?
Example.
Good answer. Okay, let me think. I'll do PO4 just to simplify it a little bit. I think I'll try this. And I'll just do the structure.
Oh, that's funky.
Okay, so this is the structure for H2PO4 minus. I've got my central atom, and there are two oxygens where I could have had a double bond, right? This oxygen could have been the one that had the double bond, and this is the one that has it. So the potential resonance structure would be to swap those two, or the resonance structure. So I could also draw this like that. And do you guys know why phosphorus has more than an octet? Because I've got
You got
2,
that minus.
4, 6, 8, 10. It's
Yeah,
because, go
you
ahead.
have that extra electron right up there.
Well, but phosphorus can have more than 8 electrons because it's in the third row, and the third row has 3d orbitals. So it can accommodate more than 8 electrons. And the way you check to see if it's appropriate is by formal charge, right? So the formal charge of phosphorus is, remember, formal charge is the number of valence electrons minus the number of bonds.
That's the number of free electrons.
Minus the number of unpaired electrons. And so phosphorus has 5 valence electrons, and this one has 5 bonds and no unpaired electrons. So it has a formal charge of 0, which is what we want.
I have a quick question.
Uh-huh.
On the left hand side of the board for the structure,
Yeah.
the oxygen on the top, and I guess the other oxygens too, I thought oxygen had 6 valence electrons and there's only 2 lines, so I'm just a little confused.
So if I were to draw the full thing. Oops, wait.
Yeah, because each line is 2, like I get
Yeah.
that. So 2, 4, 6, yeah, I get that.
This is a good
Yeah,
one.
okay. So that's how it would look, right?
Yeah, yeah.
Oh, okay. I thought, yeah, because for some reason I thought I was like doing the homework or something, and it didn't show those dots, and I was super confused.
Ooh.
Oh,
Sorry.
You're
fire
popular
department.
this morning. Um, so they might not always show a full Lewis structure. The way I drew it first was just a structure. It wasn't the Lewis structure showing all of the electron dots.
Okay, so do you want it with the dots?
If it specifies Lewis structure, put the dots in.
Okay.
Yeah.
Professor, this is
I think it's
example.
safe to do the dots on this exam too. I would go ahead and do that.
Okay, perfect. Thank you.
Don't erase this yet, Professor.
Okay.
Uh, this is a good example where I get confused. I know oxygen um, has has the structure of 6, yet we have to make it octet, so it's going to be 8 right there. It's not just if you count these all up, you come up
Uh-huh.
with an octet of 8, but um, if you just look at the number of electrons of oxygen, it's 7. It's not 6.
Where do you see 7?
See, oh, okay. Over here on the left, you
Which
got
one?
6. The oxygen over here on the left,
That one?
that one there, yes.
It has 8, 2, 4, 6, 8.
Right, but
The
oxygen,
charge, go
the
ahead.
the, uh, the charge on oxygen is only 6, correct?
The charge. So there's 6 valence electrons.
Valence electrons for oxygen, right?
Yeah.
But when you do that, you come up with 7 and 8, and that doesn't it gives you an octet. But if you just look at the valence electrons on this particular thing, there's 7 valence electrons associated with oxygen, correct?
No, there's 6.
Okay.
So I don't know if this is where you're coming from, but this negative charge is not an electron. That is the formal charge on that oxygen. So the formal
Okay.
charge is 6 valence electrons minus the number of bonds, that's 1, minus the number of unbonded electrons, that's 6. So the formal charge is -1.
So that's what.
But
Okay.
that sign is just to indicate the formal charge. It's not an electron. It's taking
Okay.
into consideration the electrons that are displayed in the unbonded pairs and in the bond.
Okay.
Is that where the confusion was coming from?
Yeah.
Okay.
Yeah.
Professor,
Uh-huh.
do we need to show that if something doesn't have a formal charge of 0? Do we need to, I mean, we would calculate it, but do you need to put it in the Lewis structure?
No.
Oh, okay.
Use it for quality control. You know what I mean? Just to check your structures.
Yeah, thank you.
Okay. Still a 3x5 card, Professor?
Yeah, 3.5 by 5-inch card included in your upload, please. You can use the periodic table. I put a link to it in the intro to the exam. And, no textbook, no internet, no other people.
I have a suggestion, Professor.
Yeah. Oh, calculator is okay too. Yeah.
All those conversion factors, can you add those to the periodic table list?
Oh, but it's on the back of your periodic table.
No, I'm talking about for milliliters of mercury to atmosphere and torus to all,
Oh, let me
all
see.
those conversion factors.
So let's see, what do we have for pressure on our thing? I don't have pressure there, do I?
No.
But you do have R, and you have the moles, the volume of gas at STP. I'm not opposed to having, I mean, you have your note card.
Mm-hmm.
So go ahead and put it on that. Um, and probably eventually I'll add it to this. But not in time. It would be too, there's
Right,
the,
I understand.
yeah.
I understand.
There's too much of a risk of failure if I try to do it now.
Yes.
Professor,
Uh-huh.
I have a question about chapter 11.
Okay.
So some of the homework, it was just confusing because like in the textbook it says that like when you're doing the equations it has to be in liters and it has
Yeah.
to be in Kelvin, but then on some of the homework you didn't need to convert it.
Yeah, you did.
I
I,
the
I
homework,
can you, is there one that you can show me that where you they give you the numbers in Celsius and in milliliters, but in order to be able to use PV equals nRT, you need to convert to liters. And that's because R has units of liters times atmospheres or millimeters of mercury over mole Kelvin. So anytime you use R, you have to have liters. Temperature, you always have to have Kelvin. Even when you have like Charles' law, which would be what?
the homework problem was like it was you had to convert it to, they gave you it in degrees Celsius, you converted it to Kelvin, but then they wanted the answer in degrees Celsius, so you
Yeah,
converted it back. Do you
yeah.
have any like trick questions like that? Because I had left it in degrees Celsius in my problem and then gotten it wrong, and like I didn't know that I need to convert it to Kelvin in the back for the
Yeah.
answer.
Yeah, so this equation will not work, and also like Charles' law, the ones that have temperature in it will not work, and it has to do with the absolute scale of temperature, because zero Kelvin is the absence of kinetic energy, and so the scaling doesn't work if you use Celsius.
Okay.
So yeah, you got to go Celsius to Kelvin, Kelvin, use Kelvin in the equation, and then if it asks for Celsius, go back to Celsius.
Okay.
Yeah. There are some questions where staying in milliliters, like Boyle's law, might work if you stay in milliliters, but I always just go to liters because it's not worth it, And hopefully you get to a point where you can see something like this and just know in your head that it's that number of liters.
Yeah.
Sorry about the glare on my whiteboard. I don't know how to, I don't know how to get rid of it.
Yeah, it's okay. I'm glad it's still up.
Yeah, God. I was so stressed out after our session on Monday. I can't believe how many things went wrong on the computer. I'm gonna knock on wood right now. It's like we got through 3 problems.
So, Professor, we have 2 hours to complete the exam.
Yeah, and it's 30 multiple choice, and I forget how many free response, but it's about the same number as the practice exam.
And it's due, when is it due again?
What did I say?
Saturday.
Saturday at 9:30 in the morning.
I think it's 11:30.
11:30.
11:30. Okay, yeah, but not 11 p.m. Make sure you know that.
Oh, it was 11:59. Sorry.
Yeah, and so my worry, yeah, make sure that I'm trying to bring up. I lost my screen. That you don't look at it and see 11:59 p.m. I had that happen in one of my other classes.
Is
Because
the exam chapter 9 to 11? I'm sorry.
it's what?
The exam, is it 9 to 11 or is it 8 to 10?
What do you mean?
The chapters.
Oh, I thought you were talking about time. It's 9, 10,
Alright.
and 11.
Okay, that's what I thought. Thank you.
Yeah.
And
And
so
also,
once you start, you have 2 hours to complete it?
yeah, but you can pick any two. And I was gonna suggest that you guys do the lab first because it's relevant to this material. But if you're solid on geometry and Lewis structures and you want to get it over with, I think you'll be fine. I think the Lewis structures on the lab are more complicated.
Thanks for that hint.
Well, I don't want you to stress out when you see, I don't want you to panic when you see the questions that are on the lab. You know what I mean? Because some of them have more than one central atom in the lab, but it's not going to be that way on the exam.
And it's all multiple choice?
No. So there's 30 multiple choice, and then there's a bunch of responses, and those are all in Canvas, but your support work you're going to write on a piece of paper. So for example, like the gas law problems, I have you solve some of the gas law problems. That question is inside the Canvas exam, but you're going to need to show your work on a piece of paper and upload that image. The uploading is after the 2 hours are up, so you don't have to worry about file upload while you're being timed.
Oh, okay.
Yeah.
That helps.
Yeah, I'm hoping this format works well. Oh, okay. Is this a polar bond?
Non-polar.
Non-polar.
It's polar. It's polar.
No,
I mean-
no, it's non-polar. CH is always non-polar.
Oh, is that a trick question, Professor?
I saw your comment, Victoria. Don't panic. Deep breaths. Was that a trick question? No.
Yeah. But isn't carbon pulling the polar over towards it?
But always remember, CH, carbon, hydrocarbons. Okay, you know that term hydrocarbons, right? That's oil and gas. Those are all non-polar molecules, and oil is non-polar, it's hydrophobic. And those hydrocarbons are hydrogen and carbon.
That's just something you need to know.
Yep.
You wouldn't do this kind of thing to us on the exam, would you?
Do what?
Put something like this on there and ask if it's polar or non-polar?
Oh, why do you think I'm showing it now?
Oh, okay.
More examples.
Thank you.
I'm not trying to steer you away from important stuff.
Okay. Non-polar.
Polar, how about this, CO, polar or non-polar?
I'm scared to say.
How do you know again?
You got this, Bill.
Awesome.
You're kind of the only one answering, so you got this, Bill.
he Yeah, I know. Well, what would you people do without Bill? They totally
Nothing.
owe you. I think we need to send him, like, you guys should be sending him thank you cards.
I know, he's asking all the questions we're afraid to ask. Thank you, Bill.
It's
You're
not like
welcome.
it's not like I can bite over the internet, you know.
Exactly.
So this one, Professor, the oxygen is actually pulling the carbon towards it, correct?
Pulling the electrons towards it, yes.
This is pulling the electron towards it. So you're going to have one of the little beta signs and a negative on the oxygen and a positive on the carbon, correct?
Yep.
Oh, what do you call those? It's
Partial
the
positive,
squiggle-
and then the
squiggle
dipole.
plus and squiggle minus.
Yeah, delta. It's a delta.
Yes. Delta. Okay. Oh man, let's see.
I'm trying to think of what else. I don't know. I feel like you guys are prepared. We'll see if I feel the same after I see the exams. Oh, and I think there's some value in this. You guys probably disagree, but there's some value in this format to the class because it forces you to engage early. Whereas, you're not sitting passively in a lecture getting some of the material. You kind of have to dive in deeper, more all along. What other questions? You guys are good on, oh, how about this? Let me see. How many electrons are in quantum level n equals 3? So the things that have quantum level n equals 3, what orbitals are those? We've got 3s, right? We've got 3p and we've got 3d. There's one 3s orbital. There's 3p orbitals. And there's 5 3d orbitals, and each one can have 2 electrons. So the total number of electrons that can have quantum level number n equals 3 is 2 plus 6 plus 10. That's 18. And then the other kind of question you might see is how many sublevels are there with n equals 3? The sublevels is the different kinds of orbitals. So the number of sublevels, the sublevels are s, p, and d. So the number of sublevels is 3.
Yeah. Maybe I'm missing something on this. At that n equals 3, looking at the periodic table, you have the 3s,
Yeah.
and then you have the 3p,
Yeah.
but there's no d going across that periodic table. It doesn't happen until you get one down below it.
Yes, but the quantum number for that row below it is 3. That's why I specify
Yes.
the
Yes.
n
Okay.
value.
Yes. Yes.
Right, because remember that this is n equals 1, n equals 2, 3, 4, but then this part, the D block is n minus 1, and these are n minus 2.
Right.
So this is D, F, S, and P blocks. I love my document camera. What's your confidence level, guys? You can put in some numbers, 1 to 10. Do I have some 8s, hopefully, or higher?
Not yet, no.
That's pretty steep.
What was that, Bill?
It's pretty steep.
Pretty steep? What do you mean
And
steep?
that's pretty steep.
I think it's going to be more of the same of what you have seen. Okay, I got a 7, 6.5. All right, Victoria, pull your pants up and do some work. So what do you need to get the other 3.5 points of confidence?
I need to do some serious studying today and tomorrow, basically.
Okay, well, that's an honest answer. I would say, you know, try to repeat your homework without looking at your book. Make your note card and work and scroll through the Pearson problems and rework them. And also the questions at the end of the chapter are very good.
Okay.
I would say for the chapter 9 material, that's the multiple choice on Pearson are good because that's where you're learning the language. It's, you know, those are all conceptual. And yeah, that's what I would say for, because I think for chapter 9, you guys know how to do the electron configurations. It's understanding what this question is asking and what this question is asking. And I think the multiple choice on the homework are the best preparation for that.
Okay.
I'm happy to answer any other questions you guys might have.
So you want us to upload the note card as well?
Yes, please.
Okay.
Right, I think you guys all have the electron configurations. Gas laws, just check your units. Check your units and know that the gas laws can be a vehicle to get N, right? PV equals nRT. There are questions in the homework like this, and I think on the practice exam. Right, if you have a reaction, you might need to use some information from the gas to get N, right? Because we know that when we have reactions, when you go from one chemical species to the other species, you have to use mole to mole ratios. So you might have to use the gas law to get N so that you can solve something with a reaction. Come on, guys, ask some questions.
Can you give an example of what that looks like? I know we have some in the homework, but could you walk us through one where we would do find N?
Yeah, let me see. I'm gonna pull up something from the end of the chapter. Okay, here's one. See if I can do this without screwing it up. Okay, so how about number 90? 89 you can do yourself and check the answer in the back, so let's do 90. So how many moles of water are required to form 1.3 liters of oxygen? So I'm gonna write this down. Okay, I'm gonna zoom out. Okay, so the question is, and here's my reaction. 2 H2O molecules make 2 hydrogen gas and oxygen gas. Okay, so the question is how many moles of H2O do I need to get 1.3 liters of O2? And so we know to go from here, and this is, we're given information that will give us the amount of oxygen, but in order to go from oxygen to water, we have to have a mole to mole ratio, which means we need to get N out of the information we've been given about oxygen. So N is equal to PV, and this is for oxygen, PV over RT. And we were given the pressure is 0.988 atmospheres. And we want 1.3 liters of it. And R is 0.0821 liters times atmospheres divided by mole times Kelvin. And it's at 325 Kelvin. So I can solve for the N of O2. Let me see by typing into my calculator. Let me see, can you guys see? I don't think you guys can see it, but I'm just going to type it in. 0.988 times 1.3 divided by 0.0821 divided by 325. And so I get the N value for oxygen is 0.048, and I can go, actually I have 2 sig figs, liters. And so I have what I want is 0.048 liters of O2. Oops, I'm off screen now. 0.048 liters of oxygen, and my mole to mole ratio is 1 mole. Oops, no, this is moles. Moles. 1 mole of oxygen. To get 1 mole of oxygen, I need 2 moles of H2O. So my answer is going to be 2 times 0.048, which will be 0.096 moles of H2O.
Man, you make it look so simple, Professor.
Well, I've been doing it longer than most of these guys have been alive.
I think the way I did it, I took that mole of O2 and I converted it to gas and then started going through the long way. You know, gas times grams of gas times moles over gas times 2 moles of 1 mole of oxygen to 2 moles of water. You can do it that way too, can't you?
Wait, so what did you start with?
Okay, I got the 0.048 moles.
Okay, good.
And I converted that to grams.
Oh, but you don't need to.
I know. I did it the long way.
Oh,
You make it look so easy when you do it.
well, if you remember that when you go from one species to the other, you need to be in moles. And if you already have moles, there is always this tendency to want to go to grams. But if you're already in moles,
Yes.
you don't have to go to grams. Okay, I got a question from Michaela.
But you can work.
Can I erase it?
Yes.
Thank you. Let's see. Okay, Michaela says, final volume. You guys see it on the chat. 1.92 liters. System is at 315 Kelvin. Is the final, wait, what is the final volume? Okay, so that's V initial. I'll do V1 of a 1.92 liter system at 315 Kelvin. And pressure is 1.1 atm if STP is established. Okay, that's a good question. Okay, so they want to know what V2 is, V final. Okay, so we know that at STP, at STP, 1 mole of gas is 22.4 liters. So what we need is the number of moles of this gas. If we have N, we can get the volume, right? And so let's see if we can get N. We should be able to. We have R, we always have R. We have T, we have P, and we have V. So we can solve for N. N is equal to PV, oops, I'm off screen. N is equal to PV over RT. So that would be 1.1 atmosphere times 1.92 liters divided by 0.0821 liters times atmospheres divided by mole Kelvin times 315 Kelvin. That will give us N. So I'm going to multiply it out. 1.1 times 1.92 divided by 0.0821 times 315. So I get an N value of 0.082 moles. Point 0.082 moles times 1 mole at STP is 22.4 liters. So if I multiply that by 22.4, I get 1.83 liters. You could, so doing this is a shortcut because we know at STP that the volume of one gas is 22.4 liters, but you could also just use PV equals nRT again and put in the conditions for STP, which is 1 atmosphere and 0 Kelvin. No, wait.
273.
273, thank you. I'm like, that won't work. Because if you put in and we just calculated N, then you'll get out volume. But STP is faster. Did that answer your question, Michaela? Oh, good. Okay. This was a good question because it's phrased a little bit differently. So I think when you're doing the gas laws, write down some equations and see what you have and figure out what it's asking for. And usually an approach will shake out. What else, you guys? Trying to think of what else. I feel like we've covered everything. What's the geometry on that central carbon?
You have three. You have three.
Yeah.
Bonds.
3 groups.
and no
Correct.
lone pair. So you've got a, a tetrahedron,
Trigonal planar
trigonal planar.
and 120 degrees.
Yes, I concur.
I'm glad you agree. um, this is tetrahedral.
Yeah, this brings up a question.
Mm-hmm.
Say you have a double bond with carbon in there,
Good job, Victoria. Yeah.
and they ask about this, and you have a double bond for the carbon.
Uh-huh. Here.
Yes, you'd look at one of the carbons and base that uh, geometry on one of those carbons, correct?
Every central atom has geometry.
Right. So if you got two, say you got carbon double bonded in here, like one of those problems we did. We had a double bond for that carbon middle.
Yeah.
Okay, that would, you'd look at one of those carbons. You would, I got confused on that. I was thinking, well, how am I going to do this?
Both of those are trigonal planar.
Okay, so you take them separate, you break them apart.
Yeah, anything on the inside has a geometry, but all these are just outer elements. They don't have a geometry associated with them because they're at the end.
Yeah.
So this molecule, it has 2 carbons that are trigonal planar. All those atoms are in the plane of the whiteboard.
Right.
The tetrahedral one has something coming out of the board and something going behind the board.
And you only count the bonds around the central atom, correct? Nothing else counts.
Correct. Yeah. You count the bonds and the unbonded pairs.
Right.
Right. So there's 4 electron groups here. Three bonds, 1 pair. So the electronic geometry is tetrahedral. But one of the legs of the tetrahedron is a pair. And so the molecular geometry is called pyramidal. And this is a polar molecule.
Yes.
Okay, there's no more questions. I think I've exhausted everything I can think of throwing at you.
Well, thanks for your help.
Oh, my pleasure. You guys had good questions today, and I'm glad people tuned in so they could get. I think it will have been good to have had extra time to go over some stuff. Good luck, everybody.
Hey, Professor, did you want us to still log on for lab, or do you just want to get started on the test? And
You know what? I'm gonna be there for the lab, but I don't think you guys need to. If you know what to do, I don't think it's necessary. But if anyone has a question, I'll just log on and be ready to help.
okay, perfect. Thank you.
Yeah, you're welcome. Okay, guys, good luck.
Thank you, Professor.
Thanks, Bill.
All right. Bye-bye.
Bye.